triangle relationship. We discussed this a little bit yesterday. Didn't write down really any official notes, so I had you guys write down the definitions. You don't necessarily have to write this down, but in review, complementary angles. They add to what?
90 degrees.
90 degrees. Supplementary angles.
180.
What are they? They add to 180 degrees. Two angles that add to 180 degrees. Perpendicular.
Intersect to form right angles.
Lines. Lines that intersect to form right angles. And how many will it form?
4.
4 of them. 90, 90, 90, 90. Then I said the two most important things you'll do in this section is the concept of a linear pair, or realizing that any time you have a straight line, what are those going to add to?
180.
I don't care how you draw it, you know the two angles created, that linear pair add to what?
180.
And you can use this by looking at the picture, where in a lot of cases, you know, just because something looks like it's a right angle, unless you see that sign right there, you can't just assume it's 90 degrees. It might be 89.5 degrees. You really think you could tell the difference? No, I don't think you could. But if it's a straight line between them, you know it adds to 180. Same thing if you're always to add 3 angles in there. But a linear pair, of course, only deals with 2 because it's a linear pair. And the other biggie, which is the new one for this section, vertical angles. Really bugs me that people forget this a lot more than they should. To me, this was one of those things in geometry that was very easy to remember. Anytime two lines intersect, they create 4 angles, do they not?
Yes.
As a result, because they're a straight line and the way they relate to each other, the opposite angles, no matter how you draw them, will always be congruent. The same measure. I don't care how you draw 2 lines. Here's another 2 lines. Guess what? Opposite angles are what?
The same.
Congruent. It doesn't matter. If that's 90 degrees, that one's 90 degrees. So if that's 30 degrees and this one's 150 degrees, what's this one?
150.
What's this one?
30.
Do you notice that the ones beside each other, what do they add to?
180. 180.
Isn't that the relationship you're always going to have?
Yeah.
Another one of those things, by looking at a picture, you can tell this. Okay? Now, in geometry, what's going to happen lots of times is we are going to supply you with some new knowledge. Stuff like vertical angles, linear pair, and then we're going to test that knowledge by saying, okay, this is the situation. Use the theorem of postulates we've given you to come up with a conclusion. So let's turn to page 9 in your little red books, and let's apply those concepts. Oh, I did forget one thing, adjacent angles. What are adjacent angles?
Angles that have a common side and point.
They're beside each other. They have a common side and what?
A
Vertex. Vertex is where an angle changes directions, right? Goes down and then changes directions. That point of, that's the vertex. Looking at number 1, they want you to write, name an angle or angle pair that satisfies each condition. Now, how am I going to write this? Well, I need to write it properly. I need to use the correct language. And I need to do it properly. I don't write them, I need to put a comma in between the angles when I write them. So first, before you decide which angle's beside it, you need to pick an angle. What angle do you want to start with?
Angle RTS.
RTS. Does everybody see that we're dealing with that angle? So angle RTS in capital letters represents points with an angle there. Comma. What would my other angle be that's adjacent to it? I actually have 2 answers. What one do you wanna,
TEN. STE.
no, TEN would not work, think about it.
ETN.
TE, that would not work for being adjacent to this one.
RTL.
Wait, ETN?
RTL.
ETN wouldn't work either.
RTL or STE?
Remember, I said adjacent, what does adjacent mean?
The
A side, so they're gonna share a common side,
Oh.
so
RTL.
STE,
There's two types of people in this world.
or, what would be the other one? RT.
RTL.
Do you guys see, I'm a little worried.
I saw.
Yeah.
Do you guys understand what I mean
They
by
have to
beside
share
now?
the
They have to
vortex.
share a side, okay? Two acute vertical angles. Acute means they're less than 90 degrees. Now, understand something here. These two, everybody look up here at the picture. These two right here, are they vertical angles?
No.
No, they're not. Why? Because if I was to extend that line, is that really the opposite angle where two of them intersect?
Mhm.
What you'll find a lot of the times, guys, is that when you're doing this, when you have these pictures with a bunch of lines and stuff in them, you need to be able to kind of erase one in your mind. Which one do I need to kind of erase here?
And
TN?
Yes.
That one right there. Now does it look like, which one's the acute vertical angles? This
yes.
one
And
and the one opposite it, correct?
yes.
So angle RT. Now why would this answer not? They're
'Cause they're
vertical angles,
obtuse.
but they are what?
Obtuse.
Obtuse. So the only right answer here is angle what? RTS. And angle what? LTE. Of course, you'd have ETL or STR too. But remember, your vertex is always, you name an angle as you would draw. So the middle point should always stay the same.
Now, why wouldn't it be like LTN or NTE?
Because it's where two lines intersect. Does that line extend? Does TN extend?
We can't see that. Great.
This
Wouldn't they
T,
still
this
be-
T, but T, it's not where, if I was to extend TN, it would go like this.
And then
Right.
they wouldn't- then it
Those
be
two would
vertical.
then be vertical angles, but I don't have a point here that they didn't draw that other side of it. This is a line, this is a line, right? They didn't finish that line. So the only ones that are opposite angles and vertical angles, they have to, this line wasn't finished, so there is no opposite angle. Now, if they did draw this, then that and that would be vertical angles, okay? What you'll find lots of times is the concepts are pretty simple, but you need to be able to pull out just what you need. There's gonna be a lot of things inside a problem that you don't need or have nothing to do with it. Right back there in the corner, right? Okay, good. Two supplementary adjacent angles.
RTL and RTN.
What is, hold up, first, what does supplementary mean?
Adds up
Equal
to
180.
Add to 180. Adjacent means they're beside each other. So they have to be beside each other, and have to add to 180. Can anybody, you know what I'd look for, guys? Straight line. So these two right here would work, wouldn't they?
Mm-hmm.
What about this one and this one? Would they work?
Yes.
And this one and that one right there would work, wouldn't it? So there's a lot of possible answers, isn't there? An example of an answer would be the first one we did, angle STR and angle RTL. I know some of it isn't, I guess I need to zoom back out. Sorry, but at the same time, you guys have this sitting in front of you as well. Agree?
Yeah.
Oh, I wrote that on the wrong one, didn't I?
Supplementary means 90, right?
Look at your notes.
Supplementary Supplementary is 180.
Why do I say that? Not because I like to be mean to Parker, but because if I answer that question for you, it doesn't sit as well if you have to go through the painstaking process of reading it again.
Then how does
Then
like
you remember it better.
oh so for that you'd have to have like one under 90 and then one above 90, wouldn't you, for them to be
Well, they could both be 90.
complimentary? Like in this
Complimentary,
case,
what is complimentary?
180.
No.
No,
Complimentary is 90.
you have it wrong.
Oh no, it's 90.
Yes.
How did you find the supplementary adjacent angles?
I looked for a straight line, because remember when I said anytime you have a straight line, remember we were doing that? Anytime you have a straight line and you have two line, you know, an angle, and you have another line that makes an angle, you know that those two add to what?
180.
So I looked for that situation on the picture. I found it here. Agreed? And you also find it right there with those two. See? You also have it here with those two there. You see what I mean? That situation happens. This is the only one where the situation doesn't happen, isn't it? Because we don't finish that line. So does that make sense? That's how I found it. I looked for that basic situation. It's a good question.
So we're looking for like a Q and obtuse angle.
No, you're looking for ones that together make a what? Make a straight line, because they got, you know, it's like a puzzle. You know, it's like this one and this one. When you put them together, you see what I mean?
Can't
They
see
make
it.
straight lines. Right? When you put those together, they make a straight line when you combine them,
And that's,
which means they add to 180. Now, but they wanted them to already be adjacent. So I couldn't just pick two that were, you know, when they don't have to be adjacent, I could have an 85 degree angle over here and a 95 degree angle over here, and they're supplementary because they add to what? 180. You see what I mean? But they wanted ones what? Beside each other. They said adjacent to. Now, if you'll notice, the last one says an angle supplementary RTS. RTS, can you guys tell me what the measure of RTS is going to be there?
70.
70, yeah.
Why?
Because the one above it's on.
RT.
One that's supplementary to it, it's the other linear pair is 110, so what's left for it to be?
70.
Everybody see that? So, or this one would be something supplementary to it, and so would an STE. Either one of those would work. It can get a little tricky when all these different things are jumbled up together. So let's just zoom in on this next picture. And I'll just talk about what the problem says, and then we'll try to highlight it one way or the other. What does the first question ask us to do with this picture? What are we finding?
Find
Two
two
obtuse
obtuse vertical
vertical
angles.
Obtuse,
And
vertical
bilateral.
angles. So your first condition is that they're obtuse. So that means what?
Oh,
Greater than 90.
Greater than what?
90
degrees.
90 degrees. The second condition is that they're vertical. What does vertical mean? Two opposite angles, they're the opposite of angles when two lines intersect. If you'll notice here, they don't really complete that line right there, do they?
No.
So that can't be, that, I can't have a vertical angle there, right? It doesn't make a kind of an X. Do they complete that line? That's a possibility, isn't it? Would you agree? That line, they don't complete that one, do they? This line, do they complete it?
Yeah.
And they don't complete any more. So that's the problem with all of this, guys, that messes with your heads. Is you need to have your own, either you need to get a highlighter and to write a bunch of figures, or you need to be able to kind of highlight it in your brain. You know, those of you that are visual people. Basically, for this question, does any of that other stuff that's not highlighted even matter?
Nope.
No, it's irrelevant. They want so the only thing they want is opposite angles where two lines intersect, so they're vertical angles and the ones that are obtuse. Which ones look to be obtuse?
T and R,
And U and S.
These two or those two?
those two.
Those two. But how would I name that?
R and T and S and U.
Well, what would I put in front of it?
Angle.
Angle R, N, T. I know you can't see what I'm writing, but I'm writing it on there. And what would the other angle be?
Angle S and U.
Angle S, N, U. So that would be the answer to number 5, would it not?
Yes.
A lot of the times in some of these pictures like this, a lot of it's just fluff. You know, they're trying to, and what we're trying to do here in these sections, and it's funny. You'll get used to this, and you won't believe that you thought this was as hard as it was when you first did it. But a lot of classes have never asked you to do things like this, okay? What geometry is teaching you is the ability to look at a problem and get out of it what you need. That's something you need in life. I know you, oh yeah, like geometry does a lot. I mean, seriously. You look at a situation, figure out what you need to solve your problem. It doesn't have to be numbers to be something you need to do like that. It's a way of thinking. And we figured out what mattered and what didn't. That's really in a lot of ways the concept of geometry. Yes?
Well, are we gonna do the next one?
Yeah, let's do the next one. Identify two acute adjacent angles. So I need two acute angles that are beside each other. And I'm talking about vertical, so I don't need the line to, you know, that looks like an acute angle, does it not? Does that look acute? So would those two work?
Mm-hmm.
Or you could have probably gone these two and these two, couldn't you? Or you could just go through here, identify all your acute angles and say which ones are beside each other. Agreed? I would say that one is acute, that one is acute, that one is acute, and that one is acute. Would everyone agree with that?
Yes.
So just name two of those that are beside each other. And you've done what they've asked, correct? What would be an angle supplementary to T, N, U? T, N, U. What is supplementary to that? Supplementary means it's linear pair, something that adds to 180.
SNU.
R and S.
No, that's its vertical angle.
SNU.
I need, remember, when I say supplementary, I want it to finish that other half to make a straight line, right?
R and S. R and
So this is my angle right here. What finishes the straight line?
R and S.
Right there, right? How would I name that? Angle T, N, R. You guys see that? See how together they make a straight line, and that would make what? 180 degrees. I know it's weird. Now let's zoom out. Oop, that's in. Let's look at number 8. Find the measure of two complementary angles if their measure is 18. What in the world are you going to do here? This does not have anything to do with the pictures. If you notice, remember, when you're confused, look at your directions. It says exercises 5 through what?
7.
So this one does not deal with that picture, does it? There is no picture for this one. So what in the world are you going to do? Well,
Start thinking of angles under 90.
measure of angle 1 plus the measure of angle 2. What do they have to equal?
8.
90.
What kind of angles are they?
Oh, 90.
Acute.
90.
No, they are
Complementary.
two complementary angles. By definition, tell me what complementary angles are.
Right angle.
No, they're not right angles.
Two angles that equal 90 degrees.
They're two angles that add to 90 degrees. If you'll notice, in essence, I have an equation there, don't I? Please stop talking in the back corner. Pay attention. Head up. What am I going to do? Well, what else do they tell me? And that's the thing. With this information, that's not enough information. It could be 40 and 50. It could be, 45 and 45. You don't know. There's a button. It could be 1 degree and 89 degrees, couldn't it? Kicker of the whole deal is they also tell you their difference is what?
18.
So the measure of angle 1 minus the measure of angle 2 is equal to what?
That's true.
Have you guys ever solved two equations with two unknowns before? What if you replace the measure of angle 1 with x and this with y is equal to 90? So that means you would replace this with x minus this with what?
Bless you.
Bless you.
You need to solve that system of equations. You can do it by a substitution method, or you can add the two together. Basically here I could add y to both sides. X is the same thing as saying 18 plus whatever y is. Everybody with me there? So whatever x and 18 plus y are the same thing. So I plug it back in to this one for x. So instead of x here, I'd have what?
18 plus y.
18 plus y plus y is equal to,
90.
what are these two combined to?
Y. 2y.
18 plus 2y is equal to 90. I'm going to subtract 18 from both sides,
72.
and I will get 2y is equal to
72.
72. Divide by 2. Y is
36.
equal to. Well, if y is 36, what's left for x to be? What do they have to add to?
So 54.
54.
54 degrees. Don't you love it when we get to redo
That
some
looks so
algebra
fun.
stuff? Make sure you write that down.